In this video, we're going to look at the steps of fatty acid synthesis. So we start with our priming reactions. So we have acetyl coenzyme A, and the enzyme MAT is going to take our acetyl group and stick it onto our ACP group that we talked about in the last video. That's our long arm. We're also going to take malonyl coenzyme A that was made from ACC, and we're going to attach that to an ACP as well. Then what's going to happen is that our acetyl ACP is going to be put onto our enzyme via KS. So we're going to attach that to the serine, or not the serine, sorry, the sulfur of cysteine, which is on our enzyme. Then we're going to have malonyl come in, and that's going to be decarboxylated, so this blue CO2 is going to be removed, and we're going to stick our acyl group that is onto our enzyme, and we're going to stick it onto our ACP. So our malonyl ACP is going to start the basis of our growing fatty acid, and then we're going to stick our acetyl group right onto the end of it. From there, we have a series of a reduction, a dehydrogenation, and another reduction event. So here we're using NADPH for reductions because NADPH is used for synthesis. And after that, we are left with a new fatty acid, C double bond O, and 3 carbon groups. So we have been recreated with we have created a new fatty acid that has 2 carbons longer. Now this will repeat where this butyl ACP will go back up here, and we'll have to load a new malonyl coenzyme A. So notice when we are adding 2 fatty acids, right, we always start with a new malonyl coenzyme A, and our chain is just added to the end of this. So our chain gets bigger, 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 but we're always adding to our malonyl coenzyme A. So that's why it says we are growing from the thioester end and not the methyl end. So the new carbons are always at this thioester right here. All the old carbons are behind it. Now, a total of 7 cycles will happen before we get our final product, palmitoyl ACP, and we need to remove the ACP, so a thioesterase, or TE, will do that for us. So our normal product of fatty acid synthesis will always be palmitate. And our overall reaction is acetyl-CoA plus 7 malonyl coenzyme A's plus 14 NADPHs plus 7 hydrogens make palmitate, 7 CO2s, 14 NADPs, 9 coenzyme A's, and 6 water. Then we can break it down even further to say we need to make these 7 malonyl coenzyme A's, we needed 7 acetyl-CoA's plus 7 CO2s plus 7 ATPs to make our malonyl-CoA. So overall, 8 acetyl-CoA's go in, 14 NADPHs, 7 ATPs, a palmitate, 14 NADP pluses, 8 coenzymes, 6 water, 7 ADPs, and 7 inorganic phosphates to make 1 14-carbon fatty acid. And that's it for our mechanism, and I will see you in the next video.